Okay guys, so this video is for those of you who are hoping to do higher level maths in 5th year. I am going on to something that I had not intended to do, and that is some new material from the Leaving Cert course. This is to give you a bit of a kickstarter for 5th year because you're in a pretty disadvantaged position now, not being able to continue with the work we had been doing, and I thought this would be a good place to go. So I'm introducing this brand new topic, something that you will have not done before. By the way, I say higher level, I really do mean traditional Leaving Cert. This topic, calculus, is on both the ordinary level and the higher level Leaving Cert course, but only on the traditional Leaving Cert, not the LCA. So this is what we're looking at, is calculus. Now, what is calculus? So calculus is an area of maths that specifically looks at rates of change. You might ask yourself, well, what the hell does that mean? But I'm explaining it now, and it's actually something that you have come across before. Specifically, you all know one way to calculate a type of rate of change, and that is slope. The slope of a line is a rate of change. It is the rate of change of the rise of the line over the run, or the steepness of the line. Calculus allows us to get the rate of change of various different equations and circumstances using specific forms of algebra that are actually quite simple to understand. Okay? People have that in their heads that calculus is this really horribly difficult area of maths. It's actually my favourite area of maths to teach at Leaving Cert, especially to ordinary level students, because ordinary level calculus is actually quite simple. But also the reason why I love it so much is because it makes up a huge section of paper 1 of the course. So of the 300 marks that you get from paper 1 in the Leaving Cert, the calculus question, the specific calculus question you will get will be between 50 to 75 marks, and there's also bits of calculus sprinkled in other bits of paper 1. So you could get anywhere from 70 to 100 marks out of 300 for just this one topic. Okay? So, as I said, it's about rates of change, which means we are talking about slopes. And this is very important that we don't forget this, okay? Whenever we look at calculus, we are looking at slope values, rates of change, stuff to do with slopes, all right? So there is some notation that we use in calculus. dy over dx or f dash x. What do these mean? What they mean is fairly simple. The reason I have to bring them up now is so you know what you're seeing when you see it, okay? dy dx means the rate of change of y with respect to x. When we talk about y and x, we are talking about the slope, the graph, the Cartesian plane graph, your xy graph, okay? And f dash x, it just means the rate of change of your function f of x, okay? So it's two different forms of notation that are both used in maths when we're dealing with calculus. You might ask yourself, why do we have these two different types of notation? This is just confusing me. The reason for this is very simple. This area of maths, calculus, was discovered, developed, invented, whatever way you want to call it, at the exact same time by two different men living in two different countries who were not in any way aware of the other's work. One of whom you've definitely heard of before, the English scientist Isaac Newton, and the other was a German scientist called Leibniz. They were both actually at the exact same time developed calculus. Okay, they both discovered it. One was using the notation dy dx, the other was using the notation f dash x. So now 300 plus years later, us people using their maths use both sets of notation. That is why. You just have to be familiar with them both. If you don't like it, tough. Get over it. Okay? So, how do I do a calculus question? So here are the rules for the simple algebra that we do when we wish to differentiate. a question. Now, if you're asked to differentiate or derive, they're basically saying carry out calculus on, okay? How we do this is pretty simple, okay? If I've got a question, let's say 3x squared, y is equal to, 3x squared plus 2x plus 4. And I'm asked, derive this quadratic equation with respect, derive the quadratic equation with respect to x. And that's the term they'll use. We carry out our calculus. So we use this. First thing you always do is write your notation. Why do you do this? This is really important. You always write your notation, either dy dx or f of dash x. This is important because you are showing an examiner, I am now about to do some calculus. Okay? If you don't show this, and then you make a mess of the question, well, the examiner won't have a clue what you're talking about. If you do show this and make a mess of the question, they might be able to see what you were trying to do and therefore see what mistake you made and still give you marks. Okay? So anyway, first thing we do, write our notation. dy over dx. Then we're going to create a differentiation. And how do you do this? Very simple. Any powers in my term, I bring down in front of the term and multiply by that number. So here we have 3x to the power of 2, 3x squared. That becomes 2 by 3x. Okay? 2 by 3x. Next, we have this. If I have a letter, a variable, this x variable, which doesn't have a power, the letter just vanishes. It disappears. Okay? Technically and another thing I forgot to say with this, we multiply by the power and we subtract 1 from the power. So that's why in my bracket it's 3x, it's not 3x squared. 3x squared becomes 2 times 3x to the power of 1. Well, anything to the power of 1 is just itself. Okay, so I forgot to mention that. Bring down the power, multiply, reduce the power by 1. Okay, here what's happening is, this is technically to the power of 1, so multiply 2 by 1, and reduce this by 1. 1 minus 1 is 0. Anything to the power of 0 is 1. So that's why the x is disappearing. And then if you have a constant here, 4 is a constant. It's always 4. Differentiation calculus is about rates of change. If I have a constant, a whole number, it doesn't change. So its rate of change is 0. So it disappears. So now I have to fully simplify this, and I get 6x plus 2. And that, folks, is my final answer. So if I want to differentiate 3x squared plus 2x plus 4, the answer is 6x plus 2. Okay, we'll get on to in another video what this actually means, but in today's class, we are literally just learning how to carry this out. Okay? So this is going to be a short video with a bunch of examples and then you learning how do I carry this in. Okay, so we have another example. Y is equal to x squared minus 7x. dy dx would be, bring down the power, reduce it by 1, so that's now x, or x to the power 1, and if there's no power, your variable disappears and you're left with your constant. And there's my answer, 2x minus 7. Now let's look at another example. Y is equal to x to the power of 3 plus 2x squared plus 5x minus 8. dy over dx. Okay? Bring down the power, reduce it by 1. So this was x cubed. We bring down our power to multiply, so we now have 3 times x. But there was a power, take 1 from the power. So it's not 3x, it's 3x squared, because 3 minus 1 is 2. Same thing here, bring down your power to multiply, reduce the power by 1, so 2x squared becomes just 2x to the power of 1 is 2x, okay? This one here, there's no power, the letter disappears, and our constant, as I said, becomes 0. It's gone. So my final answer here is going to be 3x squared plus 4x plus 5. And I'm going to do one more. Y is equal to a half x squared. Okay, so dy over dx is equal to, bring down the power to multiply, reduce the power by 1, so we get this, 2 times a half. Well, what's 2 times a half, folks? 2 times a half, or a half of 2 is 1. So the final answer would be just x. This is a simple introduction to differentiation in calculus. I'm going to be uploading this video with a series of questions that I would like you all to do for me and actually give them a proper go, alright? I don't know what you are doing at home. Maybe you are after getting a job. If you are at home doing nothing but wrecking your parents' heads, you can be doing this. This is a bit of work that will help prepare you for 5th year when you go into traditional leaving cert. Okay, and I'm going to be uploading more of these, so thanks.